Okay, this is our final Unit 4 lesson. It is Lesson 10, Part 2. We're going to talk about quadratic regression. Some of this stuff will hopefully sound familiar because we did linear regression back in Unit 2. So this same thing as the linear regression, this stuff up at the top is not applying to us. Most of us don't have TI-84s, so we can just ignore this. I'm going to show you guys how to do this on Desmos. Okay, so we are doing this on Desmos instead. Because I'm recording on my iPad, I'm going to have to put my phone up on the screen for Desmos, so it's going to be kind of small, so hopefully I can zoom in close enough. So let's go through example 1. We have this table here, so just like the linear regression, we're going to be plugging those into Desmos. So let me remind you of how we do that. So if you've got this on a phone, great. If you can, like, pull open Desmos on the side of this video so you guys can follow along and you know how to do it. Like I said, you have done it before. It's just been, probably about 2 months since we did. So what you want to do is press this little plus sign in the upper left-hand corner, and you can choose to add a table. So we do that. And I would say probably just leave things in terms of X1 and Y1. So I'm going to mark on here. We are putting this in as our X1. We're putting this in as our Y1. So we can type these all in. So it's a little weird because this format goes, in rows and this is in columns, but we could figure it out. So 0, start there, then 0.5. And something that's kind of cool with Desmos is if it's evenly spaced, it'll start to predict where you're going next. So we can just press down, and then it goes to 2. So right-hand column, we're putting in our Y1. So these are the heights. So we've got 200, then 164, 120, 68, and 8. So we have all that data right there. I'm going to throw, I think this will bold it a little bit. There we go. So that's our table. It matches what we had on here. And so it says write an equation for the curve of best fit. I'm going to write this down for you guys. What we're writing is basically standard form of a quadratic. So standard form of a quadratic is y equals ax squared plus bx plus c. So we want our quadratic to be in this form when we're done. On the Desmos app, what you do is you replace y with a y1 so that it knows that you're looking at that table. You replace the equal sign with this little squiggly guy. I know in Spanish it's called a tilde. I don't know if we call it a tilde in math. And then keep this, so you got a x1 squared plus b x1 plus c. So this right here is what we're going to be plugging in on Desmos. All right, so let me type that in for you. So right here in your next line, we do y1. And that knows that you're referencing back to the table. So now in your alphabet pad, the little squiggly guy is right here down at the bottom underneath the B and the N. So press that. M times x1 squared. I'm sorry, not M. I'm thinking back to linear regression. My apologies. A, I just wrote that down. Sorry. A x1 squared plus, then back to the alphabet, B times x1. And finally, plus C. So if I get rid of my keyboard here, these are our parameters. So this is the A, the B, and the C. And so we can plug that in. Like the equation that I've got written down, we're going to replace the A with a negative 16, the B is a negative 64, and then the C is 200. So we are going to write all that down. So we have y equals, in place of A, we're putting a negative 16, x squared, and then B was a negative 64 times x, and C was a 200. So that's our equation of best fit using x and y like we normally do, but finally for our actual answer here, we want to use the variables that they gave us. So instead of x, we're going to put a t, instead of y, we're going to put an h. So h, which is the height, is equal to negative 16t squared minus 64t plus 200. All right, so that is our actual equation for letter A. So as long as you have this down, that's what you're plugging into Desmos. That'll get you your line of best fit. Part B, how many seconds will it take? So when they say how many seconds, that means we are solving for t. Will it take for the tower to reach the ground? So reaching the ground, that means that the height is equal to 0. So that's what we're going to set up. We're going to plug in h equals 0, and then we can solve. So we will do 0 equals negative 16t squared minus 64t plus 200. In solving this, it's too hard to figure out like if it's going to be factorable or not, so I would go right into the quadratic formula when you're solving these. So a little flashback. So we've got t equals, instead of x equals, negative b, which is positive 64, plus or minus square root of b squared minus 4 times a, which is negative 16, times c, which is 200, and then all of that over 2a, so 2 times negative 16. So that's our setup. I'm going to plug a lot of this just right into the calculator. So this, we've got 64 plus or minus big square root. I'm just going to plug all that stuff in, so you'll have to trust me here. So negative 64 squared minus 4 times negative 16 times 200. And that gives me a big number, as you can imagine, 16,896 under the square root. And then in the denominator, I have 2 times negative 16. So it gives me this. So now let's plug these things in. So I'm just going to type this right into my calculator. I'll do the plus first. So 64 plus the square root of 16,896. Divide that by a negative 32. That gives me negative 6.062. Then I'll do the minus. 64 minus the square root of 16,896. Divide that by a negative 32. And that gives me 2.062. So remember, think in terms of your context. A negative time wouldn't make any sense. We're talking about an amusement park ride. This answer makes no sense. This is just over 2 seconds. Okay, so go back. This is in seconds. So that would be our final answer. Which makes sense. It was almost on the ground here. So just like a tiny little bit later, it would be on the ground. Okay, so that was our first example. We're not going to do number 2. We are going to do, let me see, number 4. Number 4 is the next one. Oops, wrong one. Let's try that again. There we go. Okay, so number 4 says, the table below shows how wind affects a runner's performance in the 200-meter dash. So we're going to go back into Desmos. And here's kind of a nice thing. See how in my number 2 right here, I already have all of this typed out? You might as well just leave that there and then just change the table. Okay, so I'm just going to go through and just change the values on my table. Okay, so I'm going to get rid of this. And then I'm going to add a new table. Oh, I shouldn't have done that. Because now I need to change these back to 1s. Okay, don't make a new table. Just change your old table. Don't do what I'm doing. There we go. So now we should be good. X1 and Y1. So I'm going to go through and add all this stuff. So we've got negative 4, negative 2, 0, 2, 4. Remember, as long as they're equally spaced, your Desmos can kind of predict it for you. 0.6, 0, negative 0.5, and negative 1.52. Okay, so you can see right here, these are our parameters. And so I can write that down as our A, our B, and our C. So I'm gonna try to keep that on the screen so I can write this down. So we have, instead of Y, they used a T. So like this is like your X, this is like your Y. So I'm gonna do T equals, A is a lovely negative 0.00321442. S squared instead of X squared. And then B is negative 0.355, so minus 0.355 times T. And then for C, we've got plus this, plus 0.03771443. So lots and lots of digits there. So we've got this long number for A, S squared, minus this number for B times S, and then that's our C. So going off the parameters that we had written right up here. All right, then it says predict the change in finishing time when the wind is negative 8 meters per second. So this is a value of S that they want us to plug in, and then predict the change in finishing time. They want us to solve for T. So solve for T, and they give us negative 8 for S. So T equals, we have negative 0.00321442. And then in place of S, we're going to plug in a negative 8 squared. So then this minus 0.355 times S, so I plug in the negative 8, and then plus 0.0377143. Lots of numbers. I'm just going to plug that right into my calculator. So I have negative 0.0032142 times negative 8 squared minus 0.355 times negative 8 and plus 0.0377143. Lots and lots of numbers. So I'm just going to round to the nearest thousandths, 2.672. All right, so this is in terms of seconds. So seconds, this means that it would improve their performance by about 2.672 seconds, which makes sense. This would be like a wind at your back, so it would make you faster. All right, so I think just kind of looking through and knowing how Desmos works, I think looking at 2 examples will be plenty.